You can use Autograph to illustrate iterative formulas and the Newton-Raphson formula, and you can use it to answer questions such as this one. So I'm going to load up Autograph again. I'm going to load up my normal page. You can see that I'm in Radians. I'm now going to enter two things. The first one is going to be the line or the curve y equals sine of x over 4 plus 1. I'm going to put that bracket in. I'm going to check the formula there. It has picked it up all correctly. I'm happy with that. There's our curve. I'm also going to insert the line y equals x. So there's that line there. Then what I'm going to do, I'm going to select using the shift key. I'm going to select both of those things. I'm going to right click and create the x equals g of x iteration. Okay, so I'm just going to click on the screen to make it colourful again. And now I'm going to try out different things. So let's try out and see what happens with a starting value of x equals 3. See what happens. So we go up to the curve, across the line, back down. Now then, I can't really see what's going on there, so I'm going to zoom in quite a lot. And this will help us to visualize exactly what's going on here. So we can see that we're creating a cobweb diagram where we go up to the curve, across the line, back down. And if we zoom in further and further and further, we can see what type of diagram we're generating here. Okay, I think as I just mentioned, as we can see, we're generating for ourselves a cobweb diagram. Okay, I'm going to zoom out so we can see that a bit better. So there's our cobweb diagram starting to form. Probably wasn't the best example to start on, so let me try out a different starting value. What if we start with -1? I can see that we're going up to the curve, across to the line, up to the curve, across to the line, and yet again, it's also zooming in on that intersection there. Okay. The question itself was all about starting with the value 0.5. So that's how that would look there. If I zoom in on this, this is the sort of thing we would hope and expect students would draw on exam day. Okay, there we go. Up to the curve, cross the line. They can do their dotted lines back down, then back up to the curve, across the line. So we've got the x0 value, x1 value, x2 value. So we've done 3 iterations. There was another curve that we were asked to do. So I'm just going to zoom on out, reset the graph. I'm going to get rid of this one. I'm then going to edit this curve. I'm going to keep the straight line. So the second equation we were given to solve was 4 minus x cubed all over 5. So that gives us that equation there. I'm going to zoom in slightly so we can see clearly what happens. So again, same as before, I'm going to click the curve, shift click, so we also select the line, create iterations. Okay, let's try with a starting value of -1. I'm just going to click somewhere else so it's colourful. We start with -1, up to the curve, across the line, back down, up to the curve, across the line, back down, up to the curve, across the line, up to the curve, across the line. This time, if we zoom in there, we can see that instead of a staircase diagram, we've got ourselves a nice cobweb diagram. You can see you've got the maths done for you over here. You can even see in the box over here, the dialog box, you've got the change in x. So we can see that the change in values of x is approaching 0, and so we're homing in on that route there. You can pretty much just keep hammering the buttons, go down so that you get it to as many decimal points or whichever degree of rounding the question asks for. So that's how you can do staircase and cobweb diagrams. Coming back to the question, I'm just going to copy the equation down. X cubed minus 3x plus 1 equals 0. So this time we're going to do it by doing a Newton-Raphson iteration. So I'm opening up my standard graph. I'm going to type in the equation y equals x cubed minus 3x plus 1, which gives us this equation here. We're told to take x is equal to -2 as our first point. What I'm going to do here, I'm going to, I have selected the curve, right click on it, and click Newton-Raphson iteration. So as the question said, can we start with -2? Now we can't quite see that, so I'm going to zoom in so we can really zoom in and see what's going on with that. So there's our first tangent at x equals -2. That cuts the x-axis somewhere between that point there. So here comes our next tangent, and we can see that we're zooming in on this point, which I would imagine is -1.879. I think my point here is, did you see how easy it is to set this thing up? You type in the equation, you right click on it, and you can just head on through the menus. It's very easy, having got this far, to then try out different values if you wanted to. So you could then talk about what happens if you try doing the same thing with a starting point of -3. We can see that we've got a few more iterations until we zoom in on that one. What if is there going to be some interesting points between here? So what if we had a starting value of -1.7? What's that going to look like? Well, it's still going to zoom in on that point there. What if it was more like -1.1? Well, what's happened there? We can see that the tangent is much further away from the graph. So this is one of those issues where if the gradient of the curve is close to 0, or in fact equal to 0, then we're going to cause ourselves some sort of problems. If we did put in that value of -1, we can see that it, as it says, it diverges and it will not solve. What about if we wanted to try and get this root over here between 1 and 2? Well, just getting my values back so we can see what's going on. Let's try one out. So let's try a value of 1.3 as our starting value. Okay, we need to zoom right in again. So there's our first tangent, and there we are, zooming in on that one there. You can imagine that if we chose values close to 1 or 1.1, somewhere like that, then we're going to get ourselves some problems. And they're going to be, you can then illustrate when this method won't work. A good one to also illustrate when the method won't work is if we use a cos value. I'm just going to close that. I'm going to reset my graph so it's nice and in the middle. Okay, so as before, select the graph, right click create, Newton-Raphson iteration. Okay, so we've got a value, which one do we want to choose? Let's start here. So if I chose, what's that, 180, 270, so if I have a starting value of 300, I would imagine that there it zoomed in on it, homed in on that root of 270. Okay, if I choose a starting value a bit higher, perhaps I can home in on that root at 90. So let me try, what if I try 230? I feel like I'm trialing and erroring the problem itself. What if I tried 350? So that's going to give us that value there. We crisscross around a bit, but we do in fact zoom in on the 90. I guess it would be possible if we changed our starting value to 255, we can probably zoom in on the 1 over -270, as we have done there. You can imagine, and it'd be a very good illustration, what's going to happen if we start at 360. Well, the tangent is going to be horizontal, it will diverge, as we expected. You may have also spotted, as I click through there, there's other things you can create, such as Maclaurin series, such as bisection iterations and so on. I won't do those now, I'll let you explore those for yourself. So what we've seen here is how you can use Autograph to demonstrate iterations and the Newton-Raphson iterations in the classroom.